we are doing our post-test notes. They're short, which is why we're doing them after the test. So we're going to start with simplifying rational expressions. So remember, when you have an expression, all you can do is simplify. Okay? There is no equal sign, so you cannot solve. So we are not solving today. We are going to actually just simplify. So a rational function is in simplified form when the numerator and denominator have no common factors. So that's what we're going to be working today with, just simplifying a rational function. So let's start with the kind you've seen before, just basic old fractions. If you remember, you're trying to find what common term do they have, and 12 is 4 times 3, and 16 is 4 times 4. So you can cancel your 4's, and your answer is just 4 over 3. Now most of you will not write out 12 is 4 times 3 and 16 is 4 times 4, but I want you to see that. I think it'll help later when we talk about factors down here. So again, you start trying to think what common term you have in 24 and 30. And 2 goes into both of them, 3 does, but even bigger, 6 goes into both of them. 6 times 4 and 6 times 5. So you cancel your 6's, and it reduces or simplifies down to 4/5. Okay, let's throw in some variables. First, let's look at 25 and the 30. So you hopefully know 5 goes into both of those. 5 goes into that 5 times. It goes into 36 times. So we canceled out the 5 that they had in common. And so I've got a 5 over here, a 6 down here, and now there's x cubed on top. There's no x's on bottom, so that will just stay. And do you remember our rule when we have variables in the fraction over each other? You subtract. So 5 minus 2 is you're going to have the leftover 3 in the denominator. So there we go. We've got 3 down. So now let's start looking at a problem like this. If you see, I have a factor of an x plus 3 here and 1 here. This is a whole item. It's a whole factor. Here's 1 down here. Since I have 1 on top and 1 on bottom, I can cancel those out. And your answer is not x plus 2, because x plus 2 is in the denominator. It is 1 over x plus 2. And that part's done. Over here, now let's look. We've got x plus 1 right here, and another x plus 1. They cancel out, and we're left with 2 over x plus 3. Okay, pretty basic. So, there is a little bit of a catch. Problem is, you're usually going to have to do what you love so very much. You're going to get a factor the expression before it can be simplified. Okay? So when I say, you usually have to factor before the fraction be simplified, which the simplifying part's the canceling part. And you know that we talk about every single time, every time you factor, what do you always check for first? And I'm hoping you all said greatest common factor. Yes, always check for that first. Always, always, always. All right, here we go. We're going to knock through these quick. We're going to look for our greatest common factor first. 10x plus 5. Oh, hello, Dolly. There's a 5 in there. Take the 5 out. Okay, let's look on the bottom. We've got we can take a 4 out. And you have 2x plus 1. Oh, look at that. You have a 2x plus 1 on top, a 2x plus 1 on bottom. Those babies cancel, and you are left with 5 over 4. Now, real quick, some of you are going to try to do something that you are not allowed to do. Do you see this 10 over 8? You can't just cancel these, because up on top it is a 10x plus 5. It's a whole thing. These are being added together. And this is a 8x plus 4. It's a whole thing. You can't cancel unless you are multiplying a whole factor with another whole factor. So don't try to slash and dash here. It doesn't work. Again, look at number 6. We can't cancel this x with this x because this is an x plus 4. This is an x squared minus 16. Cannot do, but yes, we are going to go factor. The top won't factor. What do you notice about the bottom? There's only 2 terms here, and there's not a greatest common factor. But look, there's a minus between. Is this a perfect square? Yes, it is. Is this a perfect square? Yes, it is. Factors into x plus 4, x minus 4. And then if you look, we have a whole x plus 4 factor here, a whole x plus 4 factor here. Those all cancel. And don't forget, you have a 1 on the top, x minus 4 on the bottom, and that one's done. All right, the third one over here. It's a trinomial, so I'm going to check for a greatest common factor. I do not have one. So I'm going to find out what are my two numbers that will multiply to give me negative 3, add together give me a negative 2. See if you can come up with those yourself. And hopefully you used a negative 3 and a positive 1. Doesn't matter which set of parentheses you put it in. We go to the bottom, we're going to do the same thing. It doesn't have a greatest common factor. So I'm going to find the two multiples of 6 that add together give me negative 1. Hoping you're looking at a negative 3 and a positive 2. And again, it doesn't matter which order you put these in. I could have the negative 3 over here, and if you look, I have an x minus 3 and an x minus 3. I can cancel because it's the whole thing. I'm left with an x plus 1 over an x plus 2. Can I cancel these x's? No, because this is an x plus 1. This is an x plus 2. It's the whole thing. I cannot cancel unless I have the whole thing on top and bottom like I did there. So that is your answer. Do not cancel your x's out. I might personally come to you and pop you on the head. Maybe not. All right, number 8. Check first, greatest common factor, because at first you're going, oh, I got to do magic A, but no, there's a 2 in front. Take that guy out. I'm going to put it up here. And you're left with x squared plus x minus 2. Now I can find the two multiples of negative 2 that add together to give me 1. So set up your parentheses, put your x in, and then figure out multiples of 2. You don't have too many choices. It's a 2 and 1. To get a positive 1, we need to make it a positive 2 and a negative 1. Denominator, it's got no greatest common factor. So I'm setting up the parentheses because it's a trinomial. Finding the multiples of 14. 1 and 14 weren't, but 2 and 7 look like they should work. We have a negative 5, so we're going to make it a negative 7, positive 2. Now look, we have an x plus 2, x plus 2. I happen to write mine over each other. I could have put it over here. You can still cancel. And we are simply left with the 2 times the x minus 1 and the x minus 7. Can't cancel these x's. I do not have to remultiply. We've taken the time to factor. We are not going to multiply it back out. We're just going to leave it as is. And the last one I come over to and, but oh wait, it does have a greatest common factor, right? It has a greatest common factor of an x. And if you take that out, you have x squared minus 4. Oh, and what is this? Remember what it's called? It's the difference of two perfect squares. It's going to keep going this way. It is x plus 2, x minus 2. Yeah, sometimes you have to factor more than once. We can handle it. Down here it looks like a mess, but again, look, there's a cube, there's a square, there's an x. We can take that x out. And that really helps. Okay, so now, oh wait, we just had a 14. That's pretty easy. Keep my x in front. I'm still going to use the 7 and the 2, but this time I have a positive 5, so it's going to be a negative 2 with a positive 7. So when you're all done factoring, then you can see what do you have in common. I have an x minus 2 and an x minus 2. Those are going to cancel. Here I do have an x and an x all by themselves, but see how they're different from these? This is an x plus 1. This is just an x all by itself that's being multiplied. Cannot cancel those x's because they're being added. These x's are being multiplied, so they're gone. And you end with an x plus 2 over an x plus 7. Do you have to have the parentheses? No. I put them in just so you see this is one whole thing, this is one whole thing. You cannot cancel those x's. So that's it on the notes. You flip it over. There are 9 problems that you have for homework. Thanks.